Our last example, this one's a fun one. So we've got a race car of mass 1,500 kilograms, and it has an engine capable of putting out 700 horsepower, which is approximately equal to 5.22 times 10 to the 5th watts of power. Neglecting air friction and friction on the ground and air drag, if the car begins at rest, and we assume that the car puts out its maximum amount of power, how long will it take the car to accelerate to 50 meters per second on flat ground? So, in this case, what are we going to want to use? What power formula are we going to use? Do we know what the work is? Do we know what the forces involved are? We don't really. Do we know what the change in energy is? We do know what the change in energy is. It starts at a stop. It ends at going 50 meters per second. Do we know what its instantaneous velocity is? No, because that's going to change depending. So we don't really want to go with that one because that'll give us the force, and the force isn't very useful. So the best choice for this one is power equals the change in energy divided by the time, right? We know what the time is. Can we figure out the change in energy? We sure can. We know what the, we don't know what the time is. We're solving for the time. But we do know what the change in energy is. We do know what the power is. So we're good to go. So that gives us time is equal to the change in energy divided by the power. What's the change in energy? Well, it starts at no speed, so we know that the energy is just going to be how much kinetic energy it has. So 1/2 mv squared divided by the power. Now we start plugging in numbers. We've got 1/2 times 1,500 kilogram car, right? Right, sorry. Started thinking for a little bit too long there. I was looking at my notes, sorry. 1/2 times 1,500 times 50 squared over, what's the power? 5.22 times 10 to the 5th watts. Okay, we solve that using a calculator, and that's just some, some arithmetic, complicated arithmetic to do by hand, but luckily we've got calculators. So, and that gets 3.59 seconds. And that tells us how long it would take that car to accelerate from a dead stop to going at 50 meters per second. And if you happen to live in America and you're wondering how fast that is, that's equivalent to 110 miles per hour. So 3.59 seconds to get to 110 miles per hour or 50 meters per second, that's pretty darn good, and explains why race cars are so powerful. All right, hope you enjoyed this lesson. Hope power makes sense. Just think of it as the change in work, the change in energy, and how long it took to get there. There's a great analog between velocity, between speed, and distance and energy. There's a great analog between distance and velocity and energy and power. It's the same thing. How fast are we changing? How much are we changing from moment to moment? All right, hope it made sense. Hope you enjoyed it. See you later at Educator.com. Thanks.